Okay, welcome everybody. This is a snapshot in SQL Server, a technical deep dive, and detailed lab findings. So this is Sean Myers. I'll let you introduce yourself.
Well, thank you. I know myself better than you do, actually. All right, so I'm Sean Myers. I'm a principal architect at House of Brick Technologies. I'm a consultant, so I sell billable hours. If you come talk to me, I won't sell you hardware or software, but I'll sell you other things. I'm a principal architect at House of Brick, I said, but we focused on virtualizing SQL servers, and I've been working with databases for going on 40 years now, I found out. When I was talking to a guy on the airplane on the way out here. I built my first database on an Osborne 1 back in '77 to help track my mom's Hummel collection.
That's impressive.
I know, 40 years of stuff.
Some good street cred. Myself, Rob Gerard, I'm a principal TME with Tintri. I won't sell you billable hours, but I'll gladly sell you hardware. This is a sponsored session, but this is not going to be a big marketing pitch. What we want to do is go in deep on our findings. So prior to joining Tintri, I've been an infrastructure architect on the customer side of things, mostly for financials. I've been I just hit 20 years in IT, and I've with VMware, I've got over 12 years of experience. I drank the Kool-Aid back in 2005, got my VCP then, and have been hooked ever since. And so Sean and I met back in April of 2015. We had a VMware and Tintri did this SQL expert session, and we got some of the best DBAs around the country together, put them in a lab, put Tintri storage underneath, and VMware had the servers on top and vSphere. And through the 3 days, really intense hands-on, we just kind of went back and forth, these experts and VMware about database needs and that kind of thing. And I thought, it'd be great to do a session with one of these guys. And Sean seemed to have the most virtualization savvy of them all. And that's what I was looking for, that virtual first mindset. And I thought, well, let's put it in. So we put in a call for papers, got a group discussion, did it around vNuma pNuma, which is a session we have later this afternoon if you want to attend. And then the rest is history. So this one we actually presented last year. We've refined it a little bit since. I've had the pleasure to present it several times and get a lot of feedback on it, and also have my findings kind of validated and throw through the grinder. So I'm pretty confident that the stuff I'm showing you is all legit. But take it for what it is. Do your own testing, and these are just our findings. So when we started scoping this out, we started doing a mind map. Oh, we've got to cover this, got to cover this. Next thing you know, we would have had an entire book in front of us. And so what we had to do was narrow down to get inside of an hour. So what we did is thought, let's figure out what we really care about. And one of the big ones that always comes up is application versus crash consistent. So I'm a proponent of crash consistent on Tintri, crash consistent on any file system that would act and work like Tintri, that has a lot of characteristics that I can show here. So a lot of the findings here you'll see are specific to the hardware they run on, but hopefully they do apply to you even if you're not on our systems. And so, Sean.
I'm a DBA, so I want application consistent to meet my SLAs and RPO rules. However, there are times when crash consistents are fine. Really depends upon what your business rules are. So that's what the thing is. The debate for me is not a technology discussion. It is actually a business rules discussion.
And I think that what we can do is make them both together and have a better solution. And we'll go through some of the use cases on how to do that. But a lot of the work behind this was to kind of prove out some stuff around, or disprove stuff around crash consistent and some of the boogeyman stuff that's floating around out there. The agenda is not really important because we're going to hit all the slides. So crash consistent versus app consistent. John, you want to just give us a rundown on what we're talking about?
Well, sure. Basically, the crash consistent basically means you had a power outage and the system didn't have time to flush out the stuff and shut down properly. It went down instantaneously, i.e. hardware failure, a Windows clustering failover process, an availability group on a hard failure for an automatic, not a manual, or where you're using the UI, versus application consistent basically means it's like an OS shutdown. I did right-click shutdown server, so SQL Server can despool all the stuff out of memory and can harden all the transactions properly. And it uses VSS.
It's probably worth pointing out that crash consistent in a classic server that used to have direct attached storage, the whole thing kind of went down together. In our complex environments today, we don't have that direct relationship right with storage and the compute and the application all in one box. So you've got switching in between, you've got networks in between, you've got storage that's separate, you may have different LUNs and stuff on there. And so it may not go down all clean at the same time. So this crash consistent there is really back to when it was a nice clean crash, and SQL's done an awesome job at recovering itself from those clean situations. And of course, application consistent is when we tell the OS that, hey, we're going to take a snap, quiet down.
And one thing we forgot to mention at the beginning was, if you have questions, stop us and ask us now. Just because we like to answer those questions when we're there, because it makes more sense for most people, and we want to come back at the end, it's easier forgetful. So feel free to ask the questions.
So what is a snapshot? And this is a 101, this is an advanced session, but I just want to get us all on a level baseline. There's a lot of confusion around snapshots, how they work, and so the way that I like to think about it is it's more visual. If you work with Photoshop, then this would make a lot of sense to you. So imagine here's our virtual disk, and we've got data all in it, and this disk has been filled with data. And what we're doing is we're putting another layer on top here, and then that layer is going to catch all the writes that are coming down. So if you were to think back to overhead projectors, if you had those back in school or not, we're putting these layers of transparency up, and we're writing to that top one, but we're looking through the whole stack. So here I've got some data, and I take a snapshot. And then I draw a little more data, and here I've got a nice little tree coming in, some data, take another snapshot here. I add some more data to it, another snapshot. And so the snapshots themselves look like this, right? And they look like this. And if I were to delete one of those snapshots, and they were inside the chain, and the whole chain is important as you look through the thing. If I were to delete one of them, we'd end up merging them like this. Now, unfortunately, with snapshots, we don't get the benefit of getting objects this granular, like, hey, just take those apples out. No, I'm sorry, everything kind of comes in a mix. So if we kind of continue on with this analogy of a snapshot, we take another snap, we keep going. Here's a little house I want to build in the woods. I want to go out for a little walk, pick some apples, and crap, okay. Don't worry, I can fix this. I've got a snapshot. So I'm just going to find all the data. It's all black, it's easy to identify, and I'll just get rid of it. So now we've fixed it because we've gotten rid of our corruption. We may have gotten rid of a little too much as well. So this is actually the historic stuff that we want, right? And you can see that it's not very clean. And so you'd never want to try and piece stuff together. So snapshots, you want to leave them in these chains. You can't just grab one willy-nilly here and there. They may look like they're a full copy of something. They're nice and small, but it's really that whole chain that's very important to the process. So we go back, I've rolled back now, and we'll continue with our analogy. Draw in the sun. I've got the birds there, and sorry guys, I totally forgot the data that was written because of the screw up, so I've just lost it because I didn't get a nice clean snap when I wanted it. But I'll merge that other snap in, and now everything's all good. So I merge that snap in, I get this, I think I have this, but really I have this. And this is what we want to avoid. And so if you use this model for snaps, this kind of helps explain why you can't move them off here and there. But they can be incredibly efficient if they're done really well. This is one where, Tintry, we do a fantastic job with our snapshots. And yeah.
All right, so basic definition of a snapshot. It's a point in time set of data. So it is not any scaling thing. So each snap is a different set of points of time. They can be used to recover individual items or full recovery. You can use them for multiple things, depends upon how you want to utilize them, and each tool is a little bit different. So I always tell everyone, it's just a collection of, it's a metadata file. It's just a collection of pointers on what a snapshot is, because it just points to locations on disk where your data is going to be at. The thing I stress to people, this is a new tool for you for your SQL Server recovery options. It is not a replacement for your SQL Server backups. I have clients who do use them for SQL Server backups, but you can have some interesting issues because you can't always recover, like one of his pictures when the snaps didn't lay out properly. Now you're out of luck, versus your SQL Server backups are the only way to guarantee you have your data. Not to mention a lot of SQL servers have legal compliance issues that need you to do point-in-time recoveries to up to any time in the past 7 years to the nearest second. You can never do that with snapshots because you'd have a second snapshot for each day for the last 7 years.
Well, you could with the new S3 connector from Tintry. We can send those up to the cloud into AWS and hold them as long as we want. Nice cheap storage. but we also want to make sure we're getting backups for points we're going to cover in here.
Right.
And what can we use them for? We can clone them. We can populate test and dev environments with them.
And they're great for patching, for availability groups even. You can snap your availability passive nodes, do your patching for Windows or SQL Server, and then if it has a bad patch, you can just revert the snap. And the availability group will still recover itself. Or if you're using regular physical, regular servers, virtual machine servers, you can just do a snap before you do your patching. And it works really, really well. And of course, cloning. Cloning for your dev systems to your new QA system, whatever. And they are great ways of populating those. In fact, you can do a lot of automation tools and have things just repopulate every 5 minutes or within 5 minutes from the time the DBA asks for it, which is an awesome tool.
So we can move data around. With Tintri, we've got something called Sync VM. I'll just take any of the vDisks that are in any of our VMs and present them into other VMs nice and quick. And it doesn't matter if they're terabytes in size. We can have that operation happen near instantly and not impact and take all the time it would take to send that data up through. If you're creating a .back to do something like that, there's a lot of overhead on your whole system. You got to read everything, write it to a back, take that back, send it over somewhere else, store it somewhere, extract everything, reading again, now writing it down, and it's if you could just skip that process and work with MDFs and LDFs directly to suit your purposes, awesome.
So VMware Snapshots. So we're going to talk about VMware Snapshots a little bit too because this is VMworld, but we're going to probably talk more about storage snapshots because a lot of the cool things you want to do with it are at the storage layer. But they're only at the storage layer because you're a virtual now. But anyway, the VMware Snapshots done at your hypervisor level, and you can include or not include the memory, and you do these chains. One thing, these are not long-term solutions. VMware Snapshot should be a very short-term. VMware's official statement is 72 hours, and it's usually less than 24 hours. And then also you can have some interesting consolidation issues, which I'm sure if any of you use Veeam for backups, you've seen orphan chains and had to go clean those up. So SQL Server support statement. So everyone knows, what does SQL Server actually say about doing all this? And so their official statement, which is on the KB link there, if you want a copy of this deck, just give us a business card afterwards with 3550 on it, which is...
Or just write SQL snaps.
Yeah, or snaps on it, because that way we know which session it is, because we have multiple sessions together. And we'll get you a copy of the deck too. Or it's up on VMware's website after this is over with. But, go back, Microsoft states to do any kind of snapshots in a virtual environment, you must use VSS. So it must be applications consistent. If it's crash consistent, they will not guarantee they're going to support you if you have an issue. They will usually do their best, but there's no guarantee on it. So if you need supportability, you have to go application consistent.
So this would be the irresponsible of us not to put this slide up here. Storage-based snapshots. So on a Tintri VM store, these are known as crash consistent. And what's great is that because every queue for every VM has its own lane coming in, we are NFS based, so we own our own file system. It's proprietary, written from the ground up to support virtual machines. We can take all of the bits coming in and send them off to a Delta, and we can do that super efficiently with through some log-based file systems, and and give us this nice clean snap of all the drives that we need. We don't preserve the VM state, so if something's running in memory, that is not going to be in that snapshot. Chaining is incredibly efficient, automatic, and user-proof on the Tintri VM stores. Other storage products may or may not be. They're very quick and imperceptible to the applications and the users, and that was some of our testing to see if there's any stuns or whatnot. And so what's nice about that is that because the application is not aware of it, it doesn't tamper with things the application needs. So if you're doing SQL transaction logs or anything like that, if you were coming in to do some other kind of snaps that maybe would interrupt that or would interfere with a backup doing things, these ones are just quietly there, and we can do them a lot more often. So we can give you a lot more granular rollback times. So hopefully I wouldn't have had to lose my house and everything back in that example in the beginning, because we would have had a lot more points in time. And so to quiesce or not to quiesce, so this is quiescing it. The way that we're doing it is through the VMware snaps. There's a little checkbox that says quiesce guest file system. So on our results, essentially what we're doing is that. And so what that will do is trigger VSS inside of the VMs through VM tools. And we'll see what that looks like later on.
Do we talk? Okay.
Go for it.
All right, so basically when you're quiescing, it's going to use Windows VSS, which we've kind of mentioned already. And again, all it does is it flushes your dirty pages, it brings the database into a transactional consistent state. So it actually puts a pause inside the transactional log saying this is where we're going to stop all transactions, flush dirty pages to disk, and make sure everything's going to be clean. And when that gets, it goes into all the threads ahead of it need to finish first, and then it gets its job done. And again, it's primarily used for your backups, not for rollback snapshots. This is basically when you're trying to make sure you have your recovery intervals as defined by your SLA. And you can use them to call custom scripts, which we'll show you one here in a minute or so. One of the biggest thing, though, is performance and impacts. There are snapshots that can cause minor risk of some snapshots causing database corruption. It's mostly on a setup issue, not a snapshot technology issue. And you have to work with your storage vendor on which ways to do all those.
So storage vendors should have guides out for running SQL Server on their product. Tintry certainly does. We've got a best practice guide with the simple steps to follow to keep you safe and get all the results we're going to show here. Question, feel free to come to the mic or...
How often did you see the database corruption, or did you ever see any of it?
So the question was how often in our results did we see any database corruption? We did not find any in our results. So just because we couldn't find the boogeyman doesn't mean it doesn't exist. What we were trying to do is actually find a lot of the things that people are like, careful, it could happen. I felt, well, if it could happen, how can we create situations to make that happen? So we did a lot of, hey doc, it hurts when I do this stuff. To try and do some of these things.
And we tried and we tried and we couldn't replicate it, but I have seen in the wild where this has happened. So I have customers who've done silly things and we've caused corruption issues which had to go fix. And all those I've been able to fix and fix quickly. It's just where's it come from? And it usually comes down to your snap consistency issues.
Now, it's not to say that we didn't find instances where we didn't have any database corruption, but the recovery time took a really long time, and we're going to cover this and why that happened. So our testing environment, we were using some Cisco UCS blades, a Tintry T5080 VM store, an all-flash little 2U box. We've got a virtual config. We're doing Windows 2012 R2 for the majority of these testing. The testing I've done over the past year or so focused on 2016, and all my results are showing up the same. We were using SQL 2016. The box that we used for a lot of the tests was just a little 6 vCPU, 16 gig of RAM. We didn't want too much RAM because we wanted more and more to be on disk and more risk of things. And we had at least 7 vDisks, and the different tests did it. And then for the databases themselves, we used a tool called HammerDB because this is a tool that actually works from a client over 1433 into your SQL Server and populates a database and fills it up. So on the methodology, what we're using is that HammerDB to populate and generate load. We took a variety of snaps along the way. Then we're going to take observe and see what's going on during the snapshot process, after the snapshot process, and then we're going to assess the recovery. And so when I'm taking snaps on Tintry, this is a single, like everything in Tintry is per VM, so you just go down to the virtual machine, and this is a custom snapshot policy for that virtual machine. And we're saying take every 25 minutes past the hour, we're going to have a crash consistent snapshot, and then daily, and then I put a bunch of times in there that were all kind of important to the way that I was trying to catch things before and after, because it might make a difference, your crash consistent results, if it just followed a VSS. You're kind of cheating if that's the case, and we've got a test that proves that out. And then I've got all my snapshots listing in there, and then what I'm doing is I'm cloning to a brand new machine. I'm bringing that machine up, and that's where we go in and we test it. So where you would take your snapshots, you might clone them off into a staging environment, do some tests in there, and I highly recommend that you do this and leverage that often so that you know whatever kind of snapshot you're taking meets your expectations and performs as you expect. So what we're doing to figure out timing, especially around recovery, is SQL Server starts, we boot up this VM, we go into the SQL log, we take a look here, and we're looking for the starting up database master, and then we're looking for recovery is complete of the last database. We're taking those 2 times, and we're deducing how long it took for that SQL to come up. So I'm not going to cover that slide or that one. So the tests themselves, test number 1 is called filler up. And this is creating those databases. And so what we wanted to do was, while we're filling up these databases, we want to be testing, that crash consistent versus application consistent. Does the database size matter? So maybe that makes a difference. So we had to do some tests there. What if we had multiple databases on the same disk? Does that matter? What if they're on different disks? What if our MDF and LDF are on the same disk? What if they're on different disks? What if we have a database that spans across many disks using multiple NDF files? We covered that one as well. And then what if we snap it under a lot of stress where the CPU is completely pegged? We wanted to try and get away from, hey, nice pristine lab results, and hey, what's the real world look like, and get it as dirty as we could. So in this case, what we're doing is we're taking just one SQL 2016 box, 11 vDisks on it for OS page, data and logs, tempdb temp logs, a backup, the arbitrary backup one that you throw in during install, our data 2, logs 2, data 3, logs 3, 9 HammerDB clients with databases of all various sizes coming from independent clients, so they are not taking any SQL resources. These are coming from remote systems. So when we do tax SQL, it is SQL being taxed, not applications running on there. And this is, for this test here, it's primarily write operations. This is just a table of the databases we put on there. We have about 2.5 terabytes of databases on here, and we started filling them up sequentially. And these were just the data drive, log drive, once we filled them up, and the number of data warehouses as defined inside of HammerDB. And so the max you can put in HammerDB is 5,000 data warehouses. It can take quite a while to fill this up, and you end up with a 500 gig database size. And then at the bottom, we've got our stretched one here. And the interesting thing there is watching these NDFs fill up always sequentially across, and they were never outside of one amount of delta from the others. So this is just the screenshot of a client on HammerDB while we're doing it. This is 3.4 million transactions per minute. If you ever see HammerDB results and you're filling up a database and generating it, this number is going to be a heck of a lot higher than when you're actually running the HammerDB loads. That number is going to be lower. So this is while we're filling it up, but still we're putting a good number of transactions through this system, and we want to test it. Here's our CPU of our SQL server. As we go, and I start to generate more database, and I'm taking snaps kind of throughout this stuff until we get it nice and saturated so we can see what that looks like. So during, unfortunately, the results were somewhat boring. There was nothing to be observed. We did not have any interruptions to HammerDB clients. Those things can be very finicky. In always-on availability testing that I've done, I'll see that it would drop when it tries to fail over to another. Maybe I had it set up wrong, but maybe that's just the client itself doesn't recover very well. So that actually is a good thing because most applications would have some recovery built into them to reconnect and stuff. We had something that was pretty fragile, so it was probably the canary in the coal mine we want. And then I'm going to screenshot during the quiescing, and there was stuff to observe there. So one of the things we'll observe out of the SQL log is we'll see I/O is frozen on a particular database. And those items that say it's frozen and then resumed, let's take a closer look here. There's a delta of about 5 or 6 seconds between that. There was no observed outage during that 5 or 6 seconds of quiescing, at least that we could find through our tests. But there are situations where this could be really long, and we'll cover a screenshot of that. So just seeing this alone and seeing a delta between it isn't bad. That's more of a polling time. It wasn't that you actually had 6 seconds sitting in there. So here we are filling it up, and once we do that quiet snapshot, what we're finding here is this line item that says backup, database backed up, and it says the database name, creation time, and the number of pages that were dumped. And so here is where we're looking at the recovery. So we've snapped it, cloned out the VM, brought the thing up, and now what do they look like when they're coming up? And so at the top of this, we can see this CC. So this was a way for me to name my clones to know if they were crash consistent or VM consistent so that I could keep them, tell them all apart. I still have all these snaps and these cloned VMs. If anybody ever wanted to, dig in deeper and say, well, what about this case? I keep this stuff around just because I want to make sure that the info here is solid. And yeah. So in this case, what we'll see is, let me get in a closer. We'll see that recovery is writing a checkpoint to it. And we'll see that over here, I don't know if you can see this laser pointer. You can see the number of transactions that are being rolled forward. So on a crash consistent snap, we're actually going from the last time that we've got a nice clean point in it, and we've got to roll forward all these transactions. But we're not throwing them away. We've got them there, and we're bringing them all back, and there's very few being rolled back. So the rolled back ones, the numbers we're matching between VSS and our crash consistent. However, there could be some memory, some pages up in memory that have not been flushed, right?
Correct.
And so the analysis here is when it does the recovery for a database, it will give you in that how long it took to do it. And in this case, it says the analysis phase, the redo, and the undo phase. And what's interesting here is that it seems that Microsoft used their normal progress metering to estimate how long it's going to take. And if I go back down here, down in there, I can see some messages that say it's estimated that recovery is going to take like 933 seconds. And then 2 seconds later, it says, okay, I'm done now. So, if you see those in there, look at the timestamps, because just because it said it would take that long doesn't mean it actually took that long to come back up. And so then VSS, we're looking for it, and we don't have that long list of stuff with all the analysis. We do have analysis. We come through, and what we see is that the recovery comes up much quicker, and there's a lot less work for SQL to do. And we had 1 second recovery observed from that master to the databases online. Our crash consistent, we were penalized. It took us 10 seconds longer. So by not having any of the impacts of quiescing and everything, our penalty was we had to wait 10 seconds longer when we booted this system up. To me, it's a pretty nice trade-off to be able to get really frequent snapshots every minute if you want, and get this kind of recovery.
You've already covered that, Rob.
Perfect. I forgot this part too.
Okay. Because it's memory. When you have a problem with memory. So you can snap the memory of the VM within a snapshot. It's enabled by default, which is a process. The thing, of course, when you snap in memory, it's going to make your stun time for the VM take longer. And we don't like to use it, typically speaking, but sometimes we do. Different things try and composite. The bottom bullet point, you can't natively clone the snap state, but you can do storage base, which is a very important thing. That cloning so it helps again for your test dev systems.
So, yeah, go ahead.
All right.
Yeah, just when we're taking that memory snap, we're actually writing the contents of memory down to disk, so this can take a long time. This was only a 16 gig of memory in this VM, so it's only a 16 gig file, but you can imagine you've got hundreds of gigs or terabytes inside your servers. This would take a very, very long time. And then it's like, well, what can you actually do with this? Well, you can revert your current VM into running state, but you can't natively clone any of these snaps that are like this. What I did find with Tintri is if I take a Tintri snap and restore it, then I will have a VM on there that has that snapshot. I could bring it up and recover, and when I roll back the VMware one, it goes to a running on state. Why would I want to do this? Well, if I thought there was maybe some malware or something in memory that I wanted to investigate at a certain time, then maybe I would do this. I'd pull it up in isolation and dig in and find out what's going wrong. Maybe there's a chance to save it from like some cryptoware or something like that if there's something still in memory before you've actually set the hook and rebooted this thing. Because once you reboot stuff that might be in there, you're losing all traces of memory, and investigation is going to be a lot harder. But generally speaking, just to avoid this thing, it's not very useful unless you're a lab monkey like me.
Right. So snapshot consolidation. If you've ever had issues with snap change, you have to go through the consolidation process, and sometimes it takes a long time, especially on the VMworld side. And you can have issues with your snapshot consolidation and errors, which are usually a call support to fix unless you get lucky. But also, it takes long time, especially when I go out in places and I find 2 and 3 terabyte large snapshots on a system that's only, say, 700 gig, and then go, wow, this is going to take forever to go consolidate it out. And it happens. So again, VMware snapshot should not live more than 24 hours. So recovery time. So restore a large database can take a long time with native backups. But snaps, that can be back in minutes. That comes down to is what is my RPO, RTO in things. In other words, how much data am I going to lose versus how fast can I get my production back up. So say you have some massive corruption, or you happen to have a developer who got into your production system and did an update without a where clause and deleted the entire customer table. Or it's now all Joe Smith instead of all your customers' names. Now you need to recover that. What's your best method? So you have lots of options. I have a friend of mine who works for an online gambling site. They're offshore because it's not legal in the States. Their recovery time is much, much more important than the data. They'll go find the data later on. They want to be back in seconds. So they're going to do a snap process and have that system back up. Versus other people who want the data, so they're going to go through a backup restore process, try to do a tail of the log backup for a SQL Server, and get the most amount of data and most amount of transactions. So it comes down to a business rule: which tool you're going to use. If you're going to have a quick recovery, is it more important than all your data, which you can go get your data later on and bring it in? You can use snapshots.
Now, with snaps and backups, crash consistent or application consistent, if you're recovering to them, you're going to lose data. And you're going to lose data because it's a point in time. So even if we flush everything down to disk, we take our snap, and right after it, there's some more transactions. Those aren't in the snap, right? I mean, life goes on, it moves on, and you lose that. If you cannot lose that, then you need something like synchronous replication. We've got that on Tintry as well. What that can do is make sure that your data is sent to a remote system over a wire. We'd recommend 10 gig link between these, so a metro cluster type of thing. We send it over there, and we won't ACK it back to our production VMs until the far side's received it. And so that can be an expensive overhead. In our latency breakdown, what we already show for host latency, network, and storage through the stack, we also add the latency to that far end system plus the latency of the storage there, so that if your production is slow in that situation, we can figure out exactly where that bottleneck is. So if I'm talking snaps and we're worried about how much we're going to lose between the two, and you cannot lose data, then you need something that is actively written, like synchronous replication or some of the clustering that SQL can offer.
Exactly. And also with snaps, you can go mount the copy of your snapshot to a different database server to go pull off individual records that got updated or messed up somehow in your database. So you don't have to do a full recovery of your database if you just had lost a small section. Database files, you can get corruption in just small errors, one table, and if it's not overly critical, you can just mount a snap, pull that data off, and update and fix your corruption that way too. There's many different options, and it's a great thing about snaps. Again, doesn't replace anything, just adds more tools to your tool belt.
And I got to apologize for the heat in here. It's totally out of my control, but I don't know. Thanks for hanging in there. So when we're snapping our SQL drives, it is incredibly important that we're hitting them at the exact same instant. If you do not, you will see LSN mismatches. And this is where most DBAs, Sean included, get quite upset when I talk about anything but a quiet snapshot, because there have been so many times where they've been bitten where these LDFs and MDFs and stuff don't line up and don't match.
Right, and when you're talking, it has to be the exact same instant. It can't be a half a second later or a quarter of a second later. It's basically the process of snapping needs to be the same. So every storage vendor is slightly different. Some don't offer multiple LUN, multiple data store snaps. Some do, and there's different variations of it. So when you have really high-performance SQL servers, I end up with lots of data stores and lots of disks spread very, very far to get better IOs. And so then if I'm doing snapshots, I have to make sure, if I have 12 data stores, I need to make sure all 12 data stores are snapped identically. And if I have them on different LUNs, I have to make sure that all LUNs are joined together too. So if it's in like an NFS mount, then it's one easiest thing to do, just snap the mount itself.
Yeah, so the SQL needs write order preservation. That's incredibly important for this stuff to work correctly. Tintry, we've got write order preservation. And the other thing is the consistency domain. And typically a consistency domain is only as wide as a LUN. And if you wanted to go span LUNs for a consistency domain, you would need to have something in storage that does them all together. On a Tintry box, we would have our consistency domain as wide as the entire file system. We have no LUNs on a Tintry system. It's one big bucket. You throw all your VMs and your VDI and your SQL and your change, and you violate every rule that VMware ever told you about don't mix and match these and don't exceed these numbers of VMs. And we've written ground up to do this. And we've got consistency across the whole thing. So on the SQL Server, all we need to do is we want those multiple drives, which is they live in the default home folder, the same with the VM, and we'll get all the results we're showing here.
And the biggest thing you got to worry about is making sure if you're using any of these technologies, you have to test. You have to test it a lot before you trust it enough to put it into production. Just because people just go build it, they don't test it, it's not consistent. All of a sudden I do a recovery, now I have corruption issues. Yes, I can come in and fix those corruption issues too, but it takes time. I've not found one where I haven't been able to recover all the data, but do you want to have a 4-hour outage? So make sure you've tested before you need to use it.
And if you can incorporate testing into part of your business workflow, even better. Back before joining Tintray, I was working for a fund services company out of Cayman. And in that case, what we did, we were taking several applications that all worked together, and we were snapping them at night, and we had these link clones for them the next day. And so Hong Kong would come online, and they would aggregate all the funds from all the managers and put them together. And then when Dublin came online, they would then, so this would be a whole copy of the entire environment in a sandbox, in a VLAN. They'd go in there, and then they would check the graphs and stuff, make sure it's all good. And then when Montreal came online, they would populate the stuff so that our clients could see all their numbers before the markets opened. What was happening before a procedure like that was just, oops, something didn't work right, something didn't load right, and then there's troubleshooting in production in the client's face, and you never want that. But what was valuable there is that we were testing our snapshots daily. It was part of the business process, and we could rely on those working because we had business process hitting them every day. And after a couple of years of that, I feel very, very assured that, these things are clean, and when I need them for recovery, they're going to be there. And if they weren't, then the snap right before it would be clean if we got really unlucky somehow. So if you've got lots of granularity and you did get unlucky, well, go 1 more minute back and you probably have a clean one. So this next one is long time no see. This is, did it matter if our crash consistent stuff was taken shortly after VSS? And I realized during the testing that, hey, maybe I'm just getting lucky with my crash consistent because I'm on the tail end of VSS. So my recovery here is taking advantage of the fact that some process just a few minutes earlier had done a nice clean database backup and marked the database for recovery. So what we did here was just went 12 hours since the last VSS snap under a heavy write situation. So just keep on throwing the stuff in there and then see what the recovery looks like. So during, the test results were identical to earlier. No change here. And then the recovery of it, so 12 hours earlier when I was doing those crash consistent ones, so like test 1, my results were 11 seconds. And so then in this one, I went and inspected 12 hours after that VSS operation. We get into it, and we want to see that we have the same thing going on, but it took us 13 seconds. So it took us longer, but it was only a penalty of about 2 seconds. So I thought, well, that's not too bad. It's a little bit longer. And I thought, well, I mean, there's a lot of environmental things that could add up. So I kind of retested this one quite a few times since. And it's like, there's got to be a little more to this than what I'm looking. So what's actually happening in those 13 seconds? So when you've got a certain toolbox of tools, you tend to stick to those ones. Mine is the Tintray UI. That's what my go-to. So I used it to investigate the per VM disks and stuff on it and see what was happening. And so what I found. Oh, and sorry, right before I show the other piece, this is what it looks like on the application consistent. And so what we're seeing is really clean. Rollback, four transactions rolled back. The recovery is really fast on this. Again, it was about a second from master to come up. And now we have 13 seconds versus the 11. But what was happening on disk? So we've got this concept of normalized IOPS. So storage guys, we tend to talk about IOPS. They love it. I hate IOPS. They're like RPMs in a car. And you should have seen me last night. I was like 3,000 RPMs on the highway. I was so fast. But, what gear were you in? It means nothing, right? So unless you know the block size, these IOs don't matter. Another analogy here is if you're thinking of your data payload in those IOs that are going through as people you're trying to transport, and your IO is a vehicle, you've got a highway, you've got motorcycles, you've got little 4-seater cars, you've got giant buses, you've got trains. And so when we're talking, it was only, in this case, what I'm looking at is about 1,500 IOPS. And so normalized is if we normalized it to an 8K block size, this is sort of my apples to apples meter, this is how many it would be. So instead of looking at it, it's only 1,500, on a level playing field, it's actually 5,400 normalized apps, so it's quite a bit more. And so this was with the VM consistent one coming up. These are 10-second granularity, so we boot Windows OS. The yellow is read, so we read the OS, we boot the thing up. And you can see the number of data points here. Within a minute, that thing's completely up, quiet, calm, and Windows is fully loaded and operational at that point. Now we compare that to our crash consistent one. Now, if I were just looking at IOPS, this was 2,700 and didn't seem like too much more. There's some write activity we didn't see on the other. But normalized, this is almost 40,000 IOPS. So this is, whoa, this is trains going by, not little vehicles. And so when we're looking at this, and I'm saying, hey, it only took 13 seconds. Let's say that was 15 seconds and this is 40,000 normalized IOPS. Let's say that your storage can't produce that 40,000, only gives you 20,000 normalized IOPS. Well, double that time, so now you're 30 seconds recovery. Well, maybe you're not getting that much. Now you're a minute recovery. And in another one, we're going to see that it can be extremely long. So, there is disk I/O activity, and there is a cost to these crash consistent ones on recovery. And the longer that you go from your VSS one, the heavier it is. I'll take this one.
SQL Server backup recovery. So native backup, structured properly, allows for point-in-time recovery, which means at any time I mentioned earlier, you can go to any point in time in the past 7 years, depends upon if you have enough logs. It allows you to do recovery and then roll forward to a certain spot, i.e., when I mentioned the developer goes in and drops my table, I can do a full restore, take my log files, and restore up to that last transaction. So everything that's there was already, everything that happened before that has been recovered. Your snaps are not as granular. They're at a second level or minute level, hour level kind of stuff, versus here, it is by transaction, which is why certain applications you still need to do native SQL Server backups for your recoveries on certain things. Only the completed transaction is part of your backup. So when you see in the log files, those undos and redos, that undo basically is a transaction that was partially written, i.e. say I do an insert, and I have a begin tran, I do an insert of a record, I do something else, thing crashes, but I haven't finished, I haven't given the commit. When the undo process going through, it goes up and looks and sees that the insert has been written to the disk. It goes, oh, it's not supposed to be there. I have to remove it before I can say the database is ready to go again. So it means only completed transactions in your backup files. So recovering from a snapshot, well, you're going to be app consistent, crash consistent. We've talked a lot about that. If you do your VSS snap, it's going to be app consistent. That means SQL Server is going to be happy in all instances. Versus crash consistent, you might have longer recovery times.
So data that is in memory, the page is in memory, by default on SQL, will get flushed to disk every 60 seconds. And I said that really factually this morning to Sean, and Sean said,
in most cases. Things about so SQL Server has a checkpointing process. Checkpointing process is a thing happens every 60 seconds to make sure dirty pages are flushed to disk and things are happy. However, it is a low priority process. SQL Server cares more about performance sometimes than keeping all the house cleaning in order. So if you're under a lot of pressure, it will stop some checkpoint processes. It will delay those. It will continue to push them back because you're doing so much other work. So you have to be careful about that one. So it's generally a rule of thumb, though, 99.5% of the cases you're going to see, your checkpoints are happening every minute, and you're fine. And then also, when you talk to a lot of SQL Server experts, especially if you go to SQL Pass Summit, they're going to freak out when you say, we want to do a crash consistent snapshot on my storage level for a recovery model. Because they can't stand that concept, and they have a hard time learning it or working with it. Mostly because, again, they have some of those customers who happen to have those special rules where they have to have every point in time. But for a vast majority of your workloads, I mean everything tier 3, tier 2, and a vast majority of tier 1 can deal with a crash consistent database. Again, you have to list out your SLAs, determine what you can and cannot handle. But again, I'm going to say over and over again, this is like my mantra, snapshots are not backups. You need to do both and not just get rid of, use one does not replace the other.
And snapshots typically sit on the same device of it. We talked about that chaining and stuff. So you probably want some replication strategy. Replication is great too. You also want those points in time, keep them off site. But again, the backup stuff can give us some different advantages that we may not be able to get here.
All right. SQL Server backups again, so more of it. Usually stored in separate disks, different subsystems. One thing I go make sure is make sure you push your things to a different place. Because I have a customer that my favorite story about this is they did backups using a backup media server. The backup media server was using the exact same set of spindles as their production server. The SAN went down. They said, let's bring up the database again. I'm like, okay, your backups are on the same place where your production is at. We have no copies. So if you cannot get your SAN vendor to fix your SAN, you have no company because all your data is in there and you have the oldest, newest dev version was 6 months old. So they would have lost 6 months over their production data because all their backups were in one location. Again, make sure it's stored on a separate disk subsystem. And so if your production is on an all-flash array somewhere, make sure you have a copy of that backup file somewhere else. Also, I've seen interesting things with when I'm using continuous backups on all-flash arrays, because we have a backup chain process. So if I have 100 different snaps in there, I get a corruption in snap 3, everything is still messed up. So the snap is not a long-term solution. You can use it for some situations, but there are interesting areas where I've seen them being lost. DBAs. DBA stands for Default Blame Administrator for a lot of people. We get lots of blame because when the application's slow, it's not the web server that's slow, it's always the database server is slow. And we try to push it off. And most database administrators, myself included, we are anal retentive about our data. We have to protect it at all costs. We go everywhere we want to, so we always want to know everything about it. And handing off control about the snapshots from my recovery to somebody else frightens them. It's kind of like having your newborn infant and giving it to, Uncle Larry who's got 15 speeding tickets. You're like, no. Just not that we don't trust the storage admins. We have to learn to trust. And then, of course, using a mixture gives you the most options for your recovery. It allows you to go, hey, we had an issue, now how do we solve? We can do it this way, or this way. What's going to be best for the time and the business? And then now it's a management decision. So you get together with the DBAs, the storage admins, and the manager of the application. Which one do we want to go with? How do I want to solve this problem? And make the decisions based upon facts. Recovery models. So SQL Server has 3 main recovery models, just to make sure you cover your databases. So a simple model basically is, typically speaking, means every time a transaction completes, all the logging is done. It is overwritten, disappears. What that means basically is I can only go back to a recovery point of the last day, or last time a full backup was done. I can't go to any point in time. Things that are in database simple mode are great for using storage snapshots for everything on them. Bulk logged. Basically, it's a store point on most transactions have logging. I have a concept when I do really large inserts, i.e. my daily ETL process of all these stuff from system A goes into system B. We do it between 2 a.m. and 4 a.m. I don't log all that because I can A, redo it, and B, I really don't care because it just slows down my system. And then full recovery, which is, again, allows you to have the exact point in time granularity. So database administrators, on anything we really care about, will keep everything in full mode.
So full is the default. And full is the reason that almost everybody in here who's running SQL at some point in time.
Full is not the default.
It's not the default?
It's not the default.
It's the default on mine?
Well, no. So the default is controlled by the model database.
Yeah, so model database out of the box would be full. But every database going forward, once you change that model, will then mimic whatever you do. So you change that to simple, they'll all be simple. Correct?
Exactly.
Thanks for clarifying.
Yes. So
but brand new install, that model is going to be full, right?
It's supposed to be. Okay. It's not always.
All right. So with the full, it's the reason that you've filled your drive up with an LDF because you didn't take a backup, it didn't truncate that, and so you would want to, if you want to have that, great, but make sure that thing's being truncated, or you're just, well, maybe I should say don't truncate, fill up the storage and come by more, but no, you want to definitely truncate that.
Stun time. So quiescing causes stun times to the databases. You saw in there when the logs you showed earlier what the IO was paused, no user action, IO resumed. That is called your stun time. And depends upon configuration of how long the IO pause is. It's part of the VSS process of how I make sure everything's consistent. I've seen incorrectly designed systems take over 5 minutes on a stun, as in your application stops working for 5 minutes. Granted, and of course this is on a SQL Server cluster, so every time they did that, it would fail over because it thought it was locked up. And then they have more outage on top of that. And they were trying to do one every hour, and they couldn't figure out why it was ping-ponging back and forth. And I'm like, it's a different storage vendor, by the way. Not naming names, and they're not in the room. So stun time is very, very important. Make sure. At the end of the day, I see most systems, it depends upon a lot of different factors, but between 1 and 3 seconds of stun time. And 1 second for most people is actually tolerable to get the proper consistency. On some really high-performance systems, that's not acceptable. And then you're going to have a problem with using app-consistent snapshots. Yeah.
So never-ending transaction. Here's another test, because again, we're trying to find the boogeyman here. And so what if we have something that's very non-committal? And so we wanted to figure out if there was a difference between these when we did not commit anything. So quiescing is holding these IOs back. Wait for it, wait for it, wait for it. Okay, I'm done. All right, okay, continue on. And so what if you're wait for it, wait for it, wait for it, and wait for it? And that's what we wanted to figure out here. So what we did was we used one of the max size HammerDB databases at just 5,000 data warehouses, which is about 500 gigs. And we filled this thing up, and then Sean showed me his handiwork and wrote a really cute query.
So I write really bad code. I look at bad code all day long and help customers fix their bad code, but I can't write good code myself. That's why I'm a consultant, not a developer. So I write some really bad code.
Well, so this is a great example of one that he wrote. And so what this does, or you talk through it.
Oh, no. It's called ugly cursor for a reason, because A, it's a cursor, and cursors are bad in general usually. And everything else, if you read through the rest of it, it is horrid syntax.
So we're just going to tear through line by line by line by line our whole database, looking for something, and then we're going to increment it by $3, and then we're going to do that again, and we are going to put it into a loop, and we are going to commit once that finishes.
And the way it's written, it's going to force a table scan every time and not use indexes. So instead of having to just go, oh, find the record, no, I'm going to go start at the beginning of the, 400 million rows and read through all of them every single time. Because I'm mean.
Spoiler alert, at 2.5 days into this, it still had not committed. But our tests were actually taken earlier. We tested after about 21.5 hours of this thing running. And so what did that look like? Well, during, here are the yellow are read IOPS, right? And those are our throughput at the bottom. Our throughput's running 750 megabytes per second. And it's just grinding away, and it's all read operations as it scans that table, and every once in a while, blink, blink, it pops something in. And during that snap that we were trying to find, that stun time, this is where it got nasty. So when we were snapping with the VMware snapshots, there were about 40 seconds. A lot of that's just like the polling process and the cleanup and stuff. And in this case, there were 2 minutes and 40 seconds. So there was a 2-minute timeout on top that says, okay, I give up. But during that time, it was pretty ugly. And then when it goes to remove it, instead of, so when you remove a snapshot, you are taking all the bits that sat in the delta, and now you're writing them down into your disk. And so the removal had stuff sitting in the delta, and we were trying to write it down into disk. And instead of being that 20 seconds, it was stuck for about 35 minutes. And while it's in this state, you can't do anything. You can't vMotion that thing. You can't even perform power operations on your VM. So if you've got one in that state, it's nasty. I think we've all been there. Maybe, backup processes. Maybe you have snapshots, VMware snapshots that got orphaned on there because, maybe it was a Windows update, rebooted your vCenter during a Veeam backup job or something like that. This is what used to happen to me in the past. And then I get these snaps kind of growing, and then a snap on a snap is incredibly inefficient on the VMware snapshot chains, and those removals can be nasty like this. And while it's being removed, you're like, come on, just hurry up. I'm in a bad state with VM. So when we look at it, this is a bad thing to see when you have I/O requests taking longer than 15 seconds. So when you saw that I/O is frozen, that doesn't necessarily mean it's bad. These ones are the ones to watch out for, especially the 1 second from the bottom here that says that there were 14 occurrences of this, because that is 14 occurrences of 15 seconds each. This thing end to end was offline for a very long time. So this is where the great debate of app consistent, crash consistent comes to a bit of a climax here. And so we noticed SQL database was not ready. It was, we were waiting when we were recovering these things, waiting. And we were waiting on both of them, the VSS and the crash consistent one. And when I take a look at the I/O that's happening underneath, if you're not familiar with our graphs, again, this is a per VM view of a crash consistent one. I can see equal amounts of writes and reads going on from when we booted it up. At the start of this graph, what we can see is that little read spike, that was the OS booting, and then off it goes, writing, and goes into its recovery, on and on and on and on, and it took quite a while. Hit some pretty heavy latency on here because there were a lot of operations queued up. As that latency dropped, our performance shot up. And what we've got here is the recovery. when we're doing this recovery process and we're sitting there trying to figure out, hey, where's this I/O coming from? I go into Resource Monitor, I look at Disk View, and I look down at the bottom, and I can see that it is SQL Server, and it is that MDF and that LDF that are, in fact, the ones that are being read and written to, which we would expect.
And from a SQL Server perspective, what happened was all those updates that were done need to be rolled back out because we never committed them. And so they've been ran for 24 hours, you said? More than 24 hours, and so it's
21 and a half.
It's been doing basic inserts for 21 hours. Now I have to uninsert for 21 hours. Well, in this case, the uninsert goes much faster because it's not doing the table scan process. It's just removing records.
So application consistent people rejoiced because the analysis phase took 290 times longer for the crash consistent snap. But before you get too excited, let's put it into context. My VSS took 7 milliseconds of analysis to find out, oh crap, I got a lot to do. And it took us 2,037 milliseconds. So really it was only 2 seconds. It was fine. So even though, if you wanted to play stats and numbers, you could prove something out and look how awful it is. Put it in real terms, it was a 2-second penalty. The real pain was the same operations on both. And so these took over 16 and a half minutes for these recoveries. They were about 800 megabytes per second, very solid for that time to get this up. And we were seeing things in the 30 to 40,000 IOPS range. Now, let's just say that it was 40,000 and you didn't have that 40,000 and you had 20,000. Well, take that other number, that's 16 minutes, and that's going to be now 32 minutes, right? And let's say that we only had 10,000 IOPS available to it. Now we're dropping even further, so now we're at an hour. So I can see where DBAs get pretty finicky about these recoveries and being burnt in the past of waiting and waiting and waiting, especially on older, slower storage. On all flash solutions, which this is all ran on, it does not mean that it happens instantly. It happens way faster, but we're still got to sit back and wait for things. And we still got to wait for the CPU and everything else of the SQL side. So even if your storage was there, lightning speed, there's processing that needs to be done that is more than just a storage problem. And so when we take a look at this never-ending transaction here, we've got, that's just the 290 times longer. This is that phase here. So this one, when it finally completed, took 998 seconds. And there was analysis, and then a huge redo and a huge undo. And we had the same kind of thing going on here for the other. About the same time. Why is one longer than the other? Because the snapshot was taken that much longer because we had to wait because that whole snap process was taking much longer doing that app consistent. So this is just a quick one on VSS Trace. So this is a tool you can get from the SDK. You can get it from Microsoft. And so I ran this inside to figure out what the heck's going on during a QoS operation. So in my SQL Server that I had with some HammerDB and stuff going, I had 48,000 events that were logged for that hit. And if we look, that was about 37 seconds of log data. And then if I calmed it way down, took all my databases, stopped any activity, and I still ended up having 35,000 lines of stuff. It was 35 seconds. So when I started to investigate in here, I was looking for database names, and there weren't too many instances of database names in that huge list, and they were very relevant to what was being backed up or not. So if someone says, oh, it's application consistent, something like this would give you a full trace and show you, yes, in fact, it is. These things were QoS'd, and I've gone back and forth with people around, that QoS from the VMware Snap and then leveraging VM tools, and they said, no, that doesn't do VSS. I said, yes, it does. A tool like this says, yes, it certainly does. And we go through, we can see that was a stretch database, had a little bit longer. We're looking for, in here, we're looking for that database. We've got 1 minute to go here. We found that the SQL writer was in there, the VSS provider was in there. It is doing it. We can do our VSS admin, do a list writer, and see which writer's being used. Now, you won't see which one's being used, you'll see which writers are available. The only way to really know which one's being used is something like that VSS trace that you can figure out. So if you had different backup agents on there at some point, it may not be using the provider you think it is. This is just the list of VSS admin providers. So again, do we QoS or not QoS? We take into account stun times, recovery from snaps, data loss, how many transactions are being rolled back, whether we can do that or not, supportability from Microsoft, which is why we want to have that VSS in there, So what we would recommend is that take your backup, maybe take a nightly backup, and then augment that with a whole bunch of crash consistent snaps in there. Something like Tintri offers it at a per VM level, so you could do 1-minute snaps on your most critical SQL, 4 hours on something less critical, less data change, and that'll keep the bloat of the snaps down. And that is it. Thank you very much. Please fill out the surveys. Let us know what you thought. We want to improve this.
Yeah.
And if you want a copy of the deck,
come see us. And also, since we don't have time for questions and answers, feel free to stay after. We'll stay here as long as you want to, or we're out and about. Just come talk to us and we'll answer your questions. Thank you.
Thank you.